Okay, so for today we're gonna learn about a linear function. What a linear function is, its characteristics, how to graph one by looking at its table of values, and its slope and y-intercept. So now you're probably wondering, what is a linear function? Well, a linear function is a function whose graph is a straight line. When we talk about linear function, there's mostly or commonly two forms of a linear function, which would be the standard form and the slope-intercept form. But today we're just gonna talk about the slope-intercept form, which is f of x is mx plus b. Mx is our slope, while b is the y-intercept. So now, what is a slope? When we say slope, we are talking about the rate of change. And when we say rate of change, we talk about rise over run. Where in rise, the value will go up if it's positive, and it will go down if it's negative. In the run, it will move to the right if it's positive, and then if it's negative, it moves to the left. One important thing to note about when it comes to linear functions is that the highest exponent in a linear function is 1. So let's say we have this example. Well, you can tell just by looking at the equation that this is not a linear function because the exponent of our slope is 2, and as said, the highest exponent should only be 1. A valid form of a linear function would be something like this. F of x is 2x plus 3, because you can see that the x is 1, or its exponent is 1. Now, another important thing to note about is that even if the slope is negative, it is still a valid linear function, because it would just mean that the rise would either go down or the run would either go to the left. So now let's talk about the characteristics of a linear function. One important characteristic is that the graph is a straight line and should always be a straight line. Number 2, it has a constant rate of change. Now, what do we mean by a constant rate of change? We mean something like this. When we have this, the constant rate of change is how much one number changes to the next number. So 1, 2, 3, it changes by adding 2 twice. Then 3 to 5, you add another 2. Then 5 to 7, you add another 2. Then 7 to 9, you add another 2. This is a constant rate of change because it changes per number, but it always only changes by 2 times. So 1, then 3, then 5, then 7 to 9. The last characteristic of a linear function is that for every x value, there's one y value. So here, we have this. 2 is our x, or we would say 2 is the domain, and then the y is the range. So for every x value, there should always be one y value. Okay, so let's start with an exercise where we look at these functions and we determine if the function isn't a function or is a function. So let's start with the first one. F of x is equal to 2x plus 3. Just by looking at the function, we can say that it is a linear function, but we have to check if it adheres to all the rules of the linear function, which are has a constant rate of change, and for every x value there is one y value. So we have this. This is our table of values, and we're gonna check for if every x, since there's a constant rate of change, so plus 1, we're gonna check for our y if it also has a constant rate of change. So we say 2x plus 3, and then we start by plugging in our first value, which is negative 2 plus 3, which gives us negative 4 plus 3. Negative 4 plus 3 is negative 1. Then the next one is 2x plus 3, where our x is negative 1. Negative 1 times 2 is negative 2 plus 3, which gives us positive 1 because 3 is the absolute value and it's positive. Then we have 2x plus 3 where our x is 0. So 2 to 0 plus 3. We have 0 plus 3, which gives us 3. Then 2x plus 3 where our x is 1 then plus 3. So 2 plus 3 equals 5. And lastly, we have 2x plus 3 where our x is 2. So 2 times 2 plus 3 equals 7. So we say that if our x is negative, then y is negative 1. If our x is negative 1, then our y is positive 1. Then 3, 5, and 7. So just by looking at it, we can already assume that it has a constant rate of change because for each value, it adds 2. So 1 to negative 1, it adds 2. 1 to 3, it adds 2. Then 3 to 5, it adds 2. And for 5 to 7, it also adds 2. So 2x plus 3 is a linear function. Now for the second one, f of x is equal to x squared plus 1. Like we said, a linear function's variable should only have an exponent of 1. That's the highest it can go. So this is not a function. Our 3 is negative 4x plus 5. It has the slope and then the y-intercept. So we say that it is a function. You can also try by yourself to check the table of values to check if it is a linear function or not. So now we have f of x is equal to 3 over x. Now this is not a linear function because we don't know what the y-intercept could be. So not a linear function. The last one, we have x plus 7. And like we said, a linear function has the slope and then the y-intercept. It doesn't have an exponential value of 2. So we say that this is a linear function. Okay, so next. So now that we know how to find out if something is a linear function or not, let's move on how to graph a linear function. Firstly, we start by graphing a linear function based on its tables of values. So let's use the last example, this table of values. Okay, so now that we have our graph, let us plot all our pairs. So we start with negative 2 and negative 1. Negative 2 is the x, where y is negative 1. In our graph, the x-axis is the horizontal line, whereas the y-axis is the vertical line. So we say negative 2 and a negative 1. This is the x, so we find the negative 1, which is here. Then our next one is negative 1 and 1. So we have, this is the negative 1 on the x-axis, so we go to where its pair is, which is the negative 1, which is the positive 1 on the y-axis. So then we have 0 and 3. Since our x-axis is 0, we just plot on where the value is shown, so 3 here. Then we have 1 and 5. So we say 1, then we go all the way up to 5. Because 5 is the y-intercept and 1 is the x-intercept. Then lastly, we have 2 to 7. So 2 starting from the 2 up to the 7th. So now we have all our plotted points. Now what do we do when we have all our plotted points? We connect these points to show that our graph is a straight line. Okay, so looking from this, we can see our graph is a straight line. So we know that the linear function 2x plus 3 is a function. And this is how you can graph it based on its table of values. Okay, so I have a question to ask you. Can you simply graph a linear function just by looking at its equation? If you said no, then unfortunately you're wrong. Because yes, you can simply graph a function just by looking at its equation. So we have 2x plus 3. Now what can we get from 2x plus 3? Well, this is our slope. And this is the y-intercept. So when we say 2x, first we remove the x so you can see. We will always mean 2 over 1. This is our slope. And as we said, our slope is the rate of change where it's rise over run. Our slope is positive, so we say that 2 over 1, the point will go up 2 times and it goes to the right once. So this is what we have. But we know what the rate of change is, but we don't know where to start with our graph. So that's why we have the y-intercept. When we say y-intercept, we say that in the function, we say that x is 0. So let's substitute 0. So we have 2 times 0 plus 3. We get 0 plus 3, which is just 3. Or we can simply say that 0 is 3. Since we said that the x is 0 and then this is our y. Okay, so now we have this. We know that this is the starting point. Now how can we graph? Okay, so now I have our graph here. We know that this is the first group pair that we can plot. So we say that our y-intercept is 3. So we start here at 3. Now, like we said, our rise over run or our rate of change, we say that the point goes up 2 times. So 1, 2. Then we say it moves once to the right. So 1. Now let me just erase this. Oops. So here. Now what is this point? Our x is 1 and then our y is 5. So 1 and 5. Now we can check later whether or not. So I'll write it down so you can check later whether or not it has a constant rate of change. So we have 1 and 5. Normally it is okay for your graph to only have 2 points, but let's do 3. So we have 1 and 5. So like we said, the graph goes up 2 points. So 1, 2 here. And then it says we have to move once to the right. So here. Now that we have this, so let's try just one more point just so you can really see it. So we have here, we go up twice, 1, 2, then we move once to the right. So here, which is 9 and 3. So we have 2 and 7 and then 3 and 9. You can see that for each one it adds 2, and here it adds 1. So now that we have this, we can just connect our points. Wait. My points look a little off. Okay, so now we have this. It's a straight line. It's a straight line, so we know it's a linear function. It has a constant rate of change, and for every x value, there's one y value. So now we know that this is a proper linear function, and that's how you can graph a linear function simply by just looking at its equation. Now let's have another example. Okay, so we have another example. We say that our equation is this, -1/2x plus 4. Again, this is our slope, this is our y-intercept. So we have -1/2. When we say -1/2, we either say it's -1/2 or +1/2. But for now, we will just use the -1/2. So now, like we said, a slope is a rate of change, which is rise over run. For this one, our rise, which is -1, it will go down once. Then our run, it will go to the right 2 times. Okay, so this is our y-intercept, and like we said, in a y-intercept, we just imagine that the x is 0, so it would be 0 to 4. Okay, so now we have our graph. This is our first pair that we will plot on the points. So we have 0 and 4, which is here. Now, as we said, this is our rise over run. So it will go down once, and then it will move to the right 2 times. So we have, it goes down once, and then it goes to the right 2 times. 1, and then 1, 2. So it stops here. So that is our x-axis is 2 and then 3. So the next point, 0/4, and then 2/3. So now we do it again. We go down once, and then we move twice. So here, this is 4 to 2. So 4 and then 2. So let's just do 4 points. So again, go down once and then move to the right 2 times. So what's this? 6 and 1. So we have 6 and 1. Now that we have all our points, we will connect it. So notice how in the negative slope it goes down, but in a positive slope it goes up. It goes up. So always remember that when we talk about negative or positive slope, a negative slope will go down, whereas a positive slope goes up. Now we look here again to this. We go again to this. Now, like we said, our rise over run goes down 1 time, where our run goes to the right 2 times. And we can see this here. Here it adds 2, then it adds another 2, then again another 2. Then here it goes 1, it subtracts 1, again it subtracts 1, and then it subtracts 1. So what if we want to continue it to the 5th point? So again, without graphing it, we can just add 2, 8, and then 0. Like here. Yeah, the point is here. Then we go down once. Then we go 2 times, which is here. And that's basically it. That's how you graph a linear function just based on its equation. Okay, so we have this activity where you want to open a smoothie stand and you have two options. You have plan A and plan B. In plan A, our profit for each cup is 30 pesos, whereas our rent is 1,200 pesos. For plan B, profit for each cup is 40, and then our rent is 2,400. Looking at these options, if you want to make a business, most people would want to stay safe and they would pick plan A because it has cheaper rent than plan B, which is 2,400 pesos. But in this case, we will incorporate mathematics to see which one we can profit off more. So now from this plan A and plan B, let's figure out how to turn it into an equation. So we say that X is the number of smoothies sold, where P is our profit in total. So we have P, our profit, and then X. So we say 30, which is the first equation. So 30x, since our rent is 1,200, how much our profit is in total minus how much we have to pay for rent. Because it's not add 1,200 because you're going to pay this 1,200 from the money you get here, how many cups you sell. So this is P 30x minus 200. And then for the plan B, it's 40x minus 2,400. Now, you can graph both equations to see where the point of intersection is. But then that would take way too long because there is an endless amount of numbers you would need to graph. So we would just use this. We would say that 30x minus 1,200 is equal to 40x minus 2,400. So now from this, we do as follow. So we have 30x. So since we have 30x, let's minus 30x on both sides. So 30x minus 30x. This would give us negative 1,200 equals 10x minus 2,400. Okay, so the next step on our equation is we add 2,400 to both sides, or the addition property of equality, and this one is the subtraction property of equality. So we add 2,400 here, and positive or minus subtracted to a negative, we see which number is bigger. Since our positive number is bigger, we get 1,200 equals to 10x. Then we do division property of equality, which means we divide both sides by 10, which we would get 120 over x. This is our point of intersection. And if this means this is how much cups both plans can sell but will make the same amount of money. So we said that 120 is x. Again, our equations were 30x minus 1,200 and then 40x minus 2,400. So this is the number of cups we sell. So let's see how much we can make if we sell 120 cups. Since it's the same for both of them, let's just substitute one equation. So 30x minus 1,200. 30 times 120 minus 1,200. 30 times 1000, what? Okay, since we said that 120 is our x and this is our point of intersection, let's substitute one of these equations to see how much profit we can earn if we sell 120 cups. So we have 30x minus 1200. So since x is 120 and minus 1200, 30 times 130 times 120 is 3600 minus 1200, which would give us 2400. We could also try to substitute it to this value, but since we said this is the point of intersection, we will just get the same value anyway. So we say that plan A at 120 cups is 2400, same as plan B. And now you're probably wondering, how exactly from these two options can we figure out which one can we make more profit off of? So we have plan A. Let's say that for plan A, we sell 121 cups. So simply just add the price of each cup, which is 30 pesos, so 2 for 30. Then for plan B, which is we say that for every cup we have a profit of 40 pesos. So that would mean that this would be 2440. Now we can clearly see that at first when we do plan A and plan B, the graph before 120, plan A makes more because it has cheaper rent. Back to what I was saying, or let me clarify again. Before the graph or both lines reach the point of 120, plan A actually makes more than plan B since plan B has expensive rent. But after the point of intersection, plan B starts to make more. Now let me show you an example. So we have this, like I said, at first before it reaches the point of intersection, which is 120, plan A actually makes more. So let's say that we sell 100 cups before we sell 120 cups. So P is equal to 30x minus 1200. Substitute the x, 30, 100 minus 1200. 30 times 100 is 3000 minus 1200, which is 1800. Now let's say if we do that for plan B, 40x minus 2400. So P, 40x minus 2400. So 40 times 100 minus 2400, which is 4000 minus 2400, which gives us 1600. You can clearly see that plan A makes more than plan B because it has cheaper rent. But at the point of intersection, they both make 2400. Okay, so let's say that from 0 to 500, 500 is the most amounts of cups they can sell. So for plan A, we have 30x minus 1200. So 30 times 500 minus 1200. We substitute x. 30 times 500 is 15,000 minus 1200, which is roughly around 13,000. That is on the maximum amount of cups they can sell, which is 500. So let's say for plan B, so A equals 40x minus 2400. So we have 40 times 500 minus 2,400. So 40 times 500 is 20,000. Yeah, 20,000. Then minus 2,400, which would give us 1,700, 1,000. So when we say the range of 0 to 500, 500 is the maximum amount of cups they can sell. So we have plan A, which is 30x minus 1,200. So we have 30, substitute the x for 500, minus 1,200. 30 times 500 is 15,000. Then minus 1,200, which would give us 13,800 pesos. Now let's check it for our plan B. Sorry, it's supposed to be B. So we say 40 and an x, which is 500, then minus 2,400. 40 times 500 is 20,000, minus 2,400, which would give us 17,600. Now we can clearly see that from both perspectives, plan A makes more than plan B makes more than plan A. It's because after the point of intersection, which is 120 cups, plan B will always make more than plan A, but before the point of intersection, plan A makes more than plan B. So that's why when it comes to businesses, you always have to take a risk. Or you could play it safe when you would go with plan A because you know before the point of intersection, it would make more. But if you're a risk taker, then you should take plan B because if you go beyond that point of intersection, your plan will make more than whoever picks plan A. Okay, since we've explained our business proposal and both of the plans, let's move on to our CER or claim, evidence, and reasoning. So for every claim, evidence, and reasoning, you have to answer the question. The first question is, which business plan would you recommend? A, I recommend plan A because it has cheaper monthly rent. B, I recommend plan B because it earns more profit when the business sells more than 120 smoothies. C, I recommend both plans because they always earn the same profit. That's for claim. Then for evidence, which statement best supports your claim? A, plan A has lower rent, so it always earns more profit than plan B. B, the graphs intersect at 120, and for 120 cups, you make 2,400 pesos. After selling more than 120 smoothie, plan B's graph is above plan A's because it earns 40 per smoothie while plan A earns only 30 peso per smoothie. C, both plans have the same equation, so they always have the same profit. Reasoning. A, although plan B has a higher monthly rent, it also has a higher profit per smoothie sold. Once the business sells more than 120 smoothies, the extra 10 peso profit per smoothie makes up for the higher rent and results in greater overall profit. Therefore, plan B is the better choice for a business expecting high sales. B, plan A becomes more expensive than plan B after selling 120 smoothies. C, plan B lowers its rent after selling 120 smoothies. I'll give you a moment to think. If you picked B for claim and then B for evidence and then A for reasoning, then you're correct. This is our CER. I recommend plan B because it earns more profit when the business sells more than 120 smoothies. The equations are profit equals 30x minus 1,200 for plan A and P equals to 40x minus 2,400 for plan B. The graphs intersect at 120 and they make 2,400 pesos, meaning both plans earn the same profit at that point. After selling more than 120 smoothies, plan B's graph is above plan A's because it earns 40 peso per smoothie while plan A earns only 30 peso per smoothie. Although plan B has a higher monthly rent, it also has a higher profit per smoothie sold. Once the business sells more than 120 smoothies, the extra 10 profit per smoothie makes up for the higher rent and results in greater overall profit. Therefore, plan B is the better choice for a business expecting high sales. And that's it. Thank you.